Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Addressing Channel Impairments, Techniques for BER Reduction in OFDM Communication. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the research that we have designed in depth for the OFDM communication by changing the channel impairment, and different techniques has been implemented in order to control the bit rate issues in the systems by changing the channels. So let's see what we have done. Before going to the video, let's talk about what we will cover into this video. In this video, initially we will talk about what are the application areas in which the developed system can be used. Further, we will see how to execute the code, whatever we have designed, which files are required to execute, and which software is required for the same. Then what are the current systems and what are the issues with them, and what is exactly we have done in the proposed system will be discussed. Finally, the experimental outcomes and results will be demonstrated. So let's talk about the application area. As the developed system is for the OFDM system, so OFDM system is a wireless technology part in which the wireless communication is performed by using the OFDM system. So basically the wireless communication is the application area which can be embedded in many of the areas like smart agriculture, industrial, even in the IoT, the wireless communication is playing an important role. So for a smart building, for the communication purpose, transportation purpose, in the aerospace, for the Wi-Fi and Bluetooth based communication, for the biomedical domains, so everywhere is the wireless communication. So all these domains can be covered under the developed system. Now the OFDM system that we have designed, most of the people are working in reducing the BER and AWGN and better improving the bit error rate, but nobody, and very rare studies are available, those are working in the channel impairment addressment, right? So basically what we did, let's see that. So we will provide you the code in the folder name code, under which we have different scenarios. So you can see here is one of the channel impairment is of extended pedestrian, second one is extended vehicular, third one is urban. So if you want to study about it, so you can just Google it out here. Channel in OFDM. So this will give you the details of the channel models. Those are a wide band ITU channel models. So even more details can be get by studying in detail about it. So these are basically the configuration of the channels under which the communication has been performed. So we just did that. So in order to run the code, you can go any of the folder whichever you want to run. Everyone is having the similar files, only the channel configuration is different and the analysis for the different techniques have been made. So in order to, let's say we are opening the extended pedestrian folder, so you just need to run the code. In order to run the code, you must have the MATLAB software with you. So the MATLAB version that we are using is basically the MATLAB 2019A. So you can use 2018 or the upper version, but make sure it should be a full version, not the trial one. So in order to run the code, you just need to copy the path of the file, just go to the folder where all the files are placed and paste it here. When you paste it here, you can see all the files available. We do have the 4 different scenarios in which we have implemented the techniques. So what exactly we have done? By varying the CNR, second is by varying the channel length, thirdly by changing the coefficient length, and finally by changing the packet size. So variation among the code you will see is like let's say if I'm talking about the varying SNR, the rest of the parameters in all the other factors will be same, only the SNR factor that we are giving at the initial stage will be different in order to understand the things. So here the SNR is varying from 0 to 30 dBs, whereas in second program it is varying the channel length. So you can see the SNR value we have considered for this is fixed, that is 20, but the channel length is varying. So here the major difference between the systems will be discussed later on, that what exactly we have done. So in order to run this code, you just need to click on the run button, and it will process the code and will give you the results in the terms of the bit error rate for different scenarios and different techniques. So I'm running for the varying SNR case along with the graph. You can see here we do have the graph in the terms of the MSE, mean square error, and we can see all the different techniques applied on it, that estimated PDP, constant PDP, all these techniques have been implemented and analyzed that which technique is giving the better results by changing the SNR. In the second scenario, we are also analyzing the time complexity, that how much time it is taking to process the code. So if we will talk about in the terms of the MSE, you can see the extended KL technique is providing the less bit error rate, whereas in terms of the time, the extended PDP is estimated PDP is the fastest technique. This is the case where SNR dB is varied. In second case, when channel length is being varied, you can see by changing the channel length which we have defined in it, you can see the results will vary and the time complexity and MSE has been analyzed. So you can see the MSE is quite similar, only the minimum MSE is achieved by the extended KL technique, whereas in the terms of the time, again estimated PDP technique is taking less time. For the third scenario, when the coefficient size is being varied, when I'm running this, you can see in this we have changed the coefficient size, varying the coefficient size, and by change here the S is the coefficient size which we are varying with the difference of 20 up to 100, and accordingly the coefficient size will vary and give you the results accordingly. So here it is running for the system and it will take few seconds to execute the code, and finally the results will be demonstrated in different steps. So this is how you can run the code. Now let's talk about what exactly we have done. So here this is the MSE which is increasing by changing the speed. So S is basically the speed of the device that is moving, and accordingly the time complexity and MSE are analyzed. So what exactly the variation among all these codes that we have done? So basically in all the scenarios, initially the system has been initiated and 4 to 5 different techniques have been implemented. So let's see, most of the people are working on only the OFDM system for the PAPR reduction and for bit error rate reduction, but we are analyzing it by changing the different channel configurations for the urban areas, for extended pedestrian areas, for extended vehicular areas, so for vehicles, for pedestrian, and for the urban. So for this we are applying the technique for reducing the bit error rate with the 6 different techniques. One is estimated power delay profile, that is PDP, estimated PDP. Second is constant PDP. Third one is exponential PDP. Next we are applying the Weiner filter technique. Then extended KL technique has been implemented, and finally LMMSE technique is also implemented, which is 1D. So overall analysis is to reduce the bit error rate and to check that in terms of time and bit error rate which system is performing well and for which, and for different configuration sets. And finally we are giving a reliable solution for the communication system by deciding the analysis conducted by the system. So the major variation that we have done into it is like app channel. This is the channel configuration that is set. So for the extended pedestrian, the delay profile is EP is used. The only difference among the other scenarios like extended vehicles, rest of the codes are quite similar, only the app configuration is being changed. So here you can see the delay profile is changed to EVA, rest all code is similar. Whereas in the urban scenario, you can see the app configuration is as per the urban scenario. You can read about it from the different research articles where the urban channel configuration can be seen. So all these scenarios has been given with varying the results, and then the techniques have been implemented. So you can see for the techniques, this is the constant PDP, then this is the estimate PDP. For every scenario we are implemented the techniques and analyze the results in terms of MSE and the time complexity. So further modifications are still possible into it because we are implementing the existing techniques in order to reduce the bit error rate. The proposed techniques can be further for improving more techniques, best technique out of these to get the more reduced bit error rate. So for those details, feel free to contact us. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPax, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends, synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.